Hello, this is Jack Jackson. In this video, we're going to be talking about the review problems I have at the end of the first unit on limits and continuity. At the end of each unit, I'll have a set of review problems like this. So the idea is that you've already gone through the other videos and the notes on this particular unit. You've kind of worked through this and kind of have a good idea of what's going on. And this just kind of gives you a little check. So what I'm going to do here first is I'm just going to kind of slowly scroll through the problems. If you need to pause the video, you can do that and work through the problems yourself, and then come back and watch the various videos that I have that go over the different parts, okay, and have my solutions. So you want to work them yourself and then check against the solutions. So the first set of problems we have um, this particular graph here of a relation. You see some open dots, some closed dots, obviously a piecewise defined function. And I'm going to ask you a series of questions about limits and continuity and some related questions. And if it does not exist, put D and E for the answer. So there is the picture. So you can pause on that screen to see it if you need to. And here are the questions. Is it the graph of a function, and how do we know? What's the domain? What's the range? List the set of discontinuities. X is in what set? And then here's some limit questions. I'll let you look at those, and some are evaluating functions, some are limits, and evaluate those from the graph. The second set here is just remembering some formal definitions. This first one is the definition of a limit of a function at a point, and the second one is the definition of continuity. The next section, we take this function, 2x squared plus 7x minus 15 over x squared plus 4x minus 5, and take that rational function and answer some questions about it. What is its domain? Notice that it has two discontinuities. The smaller one, x is here. Figure out what would be an appropriate set of numbers to put in a table like this to work out the to try to investigate the limit informally through a table, and then write down in appropriate limit notation what the limit is, and if it has one, and then use some sort of algebraic techniques to show that that's the limit. And what does that tell us about the graph? And the same thing for the larger of the two discontinuities. And then you want to do end behavior as it goes way to the left and right, and look at a table that investigates that, and state your conclusions and appropriate limit notations, and use some algebraic techniques. And what does that say about the graph? And then graph it. You can put a computer generated graph, you can do it by hand. And here is some other questions. Which of the following classes consist entirely of continuous functions? Circle all that apply. And in fact, all of these are functions that are continuous where they're defined, but some of them aren't defined everywhere. Some fill in the blank and short answer questions there. Some pre-calculus and calculus stuff here. The next one dealing with the formal definition of a limit using the epsilons and deltas. We use those for a specific purpose earlier, and we need to figure out what an appropriate delta would be given this epsilon for all the inequalities in the definition to work out correctly. Those epsilons and deltas should show up in this formal definition of a limit somewhere up here. Number 2A. Same thing for this one, but give delta as a function of epsilon here. Epsilon is a variable. Hint, simplify this first. And then here's some limits that we're trying to compute from a formula. You want to show algebraically how these worked out using some of the techniques we developed earlier in the notes in these videos, and then you're encouraged to check them through tables and graphs as well. So here's one, there's another one, and another one. This one deals with the class of functions here. You need to identify what the class is. F of x equals x to the p over q power, where p and q are constants, and its reduced fraction, greatest common denominator, greatest common divisor, or greatest common factor of the p and q are 1. And just some fill in the blanks and fill in the blanks in these tables here about that one. So let me pause on that just a second so you can see it. There you go. And next, here's some things where you have to come up with a formula for a function. Some of these, there's more than one answer. Some of them, there are only one answer. But try to come up with an appropriate formula that meets the conditions. Of course, each one of these is separate. Let me fix that to where the numbering goes where it's supposed to be. Okay. And of course, each one of these is separate. These are not the same function. These are what, 6 different functions that you have to come up with. So you're supposed to come up with a formula like f of x equals something. Here's a table here. Can you come up with an appropriate formula for this table? And similarly for this one here, it should be a basic kind of function that we've studied. And here's some matching. We have some graphs of functions, and you have to identify what kind or class of function it is matching over here. Answers can be used once, more than once, or not at all. But the answers will be capital letters based on chosen from this list. Here are a couple of tables, and you need to come up with formulas for those. And here is some ideas, looking at some basic graph shapes and just identifying some things about them and which one fits this table best. And here is a couple of real-world problems. This one is about a freezer depreciating at a constant percentage rate each year, and write a formula out and so forth to answer some questions about that. And the last one, I'll let you read that on your own. You can pause that. And let's see. This one here has 3 different functions. Here, f of x is given by this table, h of x is given by this formula, and g of x is given by this graph. And you have to evaluate various things, including some inverse things and composition, and solving equations and so forth. This one here is dealing with the graphs of, let me get back on that one and make sure you can maybe stop there or there. And this one has several lines. Let me get to this, get that where you can see that. They're labeled by numbers, by letters. And you have to answer which ones have a positive slope, list all the letters that apply, and which ones have negative slope, and so forth. So this is dealing with equations of lines and making sure we understand the basics of what slope has to mean, what it means to us. I think I already had this question up earlier. So let me just get rid of that one. We already had that one. And then we'll have some solutions here. Okay, so I'll come back in the next video and we'll go over the solutions.